is ROHITH AMBADI.S. I'm an assistant professor of mechanical department in PSN College of Engineering and Technology. Today we are talking about standard quality control and inspection. The subject is to improve the quality and of a product and reducing the errors and make a standard for the whole process. This subject entirely focuses on the additive manufacturing. So additive manufacturing chapter, first unit we are discussing about introduction to additive manufacturing, importance of standards, importance of quality management, standards, quality control, measurement device, ISO, work plan, and roadmap of additive manufacturing, priorities of area of additive manufacturing, standardization. Why we need additive manufacturing? Need a standardization, type of AM standards. So basically we are just focusing on this standard quality control and inspection on additive manufacturing only. This is more likely to like a process planning subject, like a business class program. This subject is majorly to plan everything, to reduce the errors, make sure it improve the quality, make sure the product lifetime to increase. These kind of things have to be improved by putting several rules. These rules are called standards. During these standards, and we have to control the whole process. That is called quality control. And after this process is done, we check the each every step. It is done right or wrong. This is for the inspection. Okay, let's just deep into the subject. Additive manufacturing. Definitions and importance. Additive manufacturing is a manufacturing process in which three-dimensional objects are built layer by layer, direct from the digital model. So typically materials such as polymers, materials, ceramics, and composite. So some people are asking additive manufacturing. What is that? Additive manufacturing. Additive manufacturing, very simply we can ask 3D printing. So everyone is 3D printing. So everyone now it's a very easy subject. It's a three-dimensional object built by layer, and directly image insert by a digital model. Okay. So this is something you have to see that in milling, drilling, grinding, or some this kind of process will do that. Substitution of machining, removal of a material by physical or chemical process. These are the processes like milling, grinding, or water jet cutting from the layer. This is a traditional method of making an object. Now additive manufacturing or 3D printing means added layer by layer of material. Now you can see that. Also, why additive manufacturing is better? The material, we can see that there is a two type of material, A and B. A is like milling or drilling, machining will be done, and material will be there. And the waste of the material, you can see it's very large. Now here, the part B, it's for the additive manufacturing or 3D printing. We just go to the additive and layer by layer making, and material is done. You can see the waste is very less. So compared to traditional manufacturing, when it comes to 3D printing or additive manufacturing, the waste is very less, but the time taken for the process will be huge. And we can reduce the time by, we can change several its length or some few other research that is going on this subject. In our college also several people are doing very deep down research on additive manufacturing, 3D printing, how to improve its life, everything. We don't have to discuss about that. We just understand, okay, this is additive manufacturing. We just want to look into the how to improve the production and what are the areas can be covered, how to control, how to improve the product, how to improve the process, this, and what are the rules we should implement. These are the things we are focusing on this subject. So key characteristics of additive manufacturing: railway fabrication, that use of CAD models without using models or tools, and complex fabrication can be done, mass customization can be done with the minimal cost generation. Suitable, it's well-known parts can be made, reduce the material waste, some digital products can be increased. We can do the simulation models, everything. If we have to make it something bigger, we can make a small model and check it with the experiment aerodynamics to check the dimensions, check the its wind nature or anything. We have to check the like we have to build something building like for the civil or something aeronautical anything. We build by using the 3D printer, take the using experiment aerodynamics or something to check the airflow velocity of the material, characteristics and everything we can touch and make. Then we can make the original material. So this is can be used for prototype. And we can change several prototypes easily and check for each one, and we can build by later. So additive manufacturing has several advantages, but the subject is not for additive. Yeah, this subject is for improving the entire process of additive manufacturing. Okay, everyone knows ISO, and now just see that this is a process. We just build a CAD software, use this CAD software to build something, and slice these details how this software how to run, and additive process and things like that. These four stages of making an object. Like first we have to make a CAD model. Inside this CAD model software, 3D printer software, it will slice the data and divide by each layer by layer. Then the additive process we will run, and we just take the process and give a finishing parts, and this we get a better product. Importance of advantages. Additive manufacturing is important because it can give both design freedom and supply chain strategy, allow the lightweighted proposal. So many things can be done. We can make customization, changes, mass production. We can do several advantages. In system level, additive manufacturing can reduce the material waste, shorten the lead times, support the on demand or parts production. Like if you have a bike or something, you lose a one part. You cannot, even the manufacturing cannot give you manufacture. Like Royal Enfield or any manufacturing, they don't have any spare parts for that. So you can use the dimension, just give to 3D printing. There's 3D printing will run the project, you can use it. So these kind of advantages is there. 3D printing. And there's some news where people are using 3D printer to make a guns, and which is illegal. Don't do that. Okay, next goes to this is a model additive manufacturing, then material jetting, and 3 or wet fusion, sheets lamination, direct energy dispersion, material extraction, window jetting, VT photo polymerization. These are additive manufacturing. Application of additive manufacturing: aerospace, lightweight structures, automobile, rapid control, biomedical, industrial manufacturing, custom products like jewelry, footwear, these things are done. Nowadays Adidas and clothes, their shoes are made by 3D printing. And most of the jewelry is also using complex dimension jewelry is done by using 3D printing. And people are using photos and something, the mark jigs and everything can be using 3D printing. I also just talk about the aerospace. Aerospace means we just make a prototype about tools or material, just camera and give to the 3D printer. 3D printer will do the work. Okay, this is one of the material extraction and we use. We can use this. There is a foil in which the material will be there, and material will be by layer by layer. This polymer based, filament based, screw based. You can see it's like a injection molding. This is a material by using a force. This nozzle will give the material inject to this material. This pipeline, and slowly the piston will go down and material will come outside. It's very simple. It's like a syringe or piston like that. By loading the liquid tank, the piston will go down. Due to the pressure, material will come outside and it will create the layer construction. Okay. And filament base. This is another method. Same like this first method. We are using two rods, or we can say, and this is the filament. This filament goes here. Sometimes we will heated this material at just level this angle time. This is a screw method. We will crush the material and combine the material together, and voila, the material will be done. So this is something basically. Okay, I did an invitation. Okay, now we are just going inside the main topic. Quality control management and role of enhancing the performance reliability in additive manufacturing. Quality manager. In additive manufacturing, spends a structured framework for planning, onboarding, monitoring, and improving the additive manufacturing process. Ensure that 3D printing components meet the required functions in a mechanical specification. Because of additive manufacturing involves layer by layer fabrication, fall vibration, or material free temperature, or machine calibration, significantly effect on the final part. A robot quality management system is minimize such as the deviations and reduce the damage to the material, and label of the product can be increased. So you can see the quality management material constantly detect the identification, repeatability to produce the material again and again, variability, improve the dimensional accuracy, enhance the integrity, reliability. So it's like by every time, each and every time we have a quality management system. We make sure our product have a better life, better quality. We can constantly make this product every day without any problem. Some people are they are making hundreds of material per day. They will make a better product will 30 or 60 something. But if you have a quality management system, every day if it's we need 100 product, they will give you 99 product will be better product. They have a less defects compared to the companies that does not have a quality management system. Strengthening process of reliability through the standardization on control. And additive manufacturing such as slim, EBM, these are have a very good nature. This will be improve our process, entire process. Process controlling SOPs that define the machine setup. AOS will for the standards, how the process will done, how it's for the global unification. Like the machine will be produced in Germany or somewhere, and it will come to India. We have to make sure, okay, this is all the things common in there, and the work is time period, rules, safety procedure, everything will be under the ISO regulation. And material qualification, by buying something from one company, we have to, okay, this company have this kind of qualification, that means this material have a good framework, material can be trusted, we can use it. Establish ISO. Now you can see that modern quality framework. This is something to inspection the entire system. By doing the entire process, we can check this process running right over. Like ATM. We go to ATM, put some pin code, get money. During that time, if the ATM probably sensor something, okay, this person take the money out, okay, it's done. Something like that. This is a feedback system. It will monitor everything, every process. Like a proximity sensor, riser sensor, every sensor, thermal sensor, everything will be placed on the each end of the process. So if there is some kind of mistake will happen, we can check it and we can take action of it. Okay, this product is continuously product is coming in space, so we can take action, stop the process and remove the wasted material and try to fix the machine and everything done on the period and make a better result or make a better product. So modern additive framework is integrated to situation based monitoring system like negative phone sensors, thermal sensors, thermal camera, laser powered feedback system, and proximity sensors. These sensors will detect any abnormality happen during the process, like porosity, bearing, lack of fusion. This kind of it will detect and to give us, okay, this is happening, we can fix it. And adjusting the scan speed law, laser power, or rotating some more linear movement or something, we can fix the material, get a better result. And this will give you mechanical strength, surface finishing, dimension accuracy, reliability. Data-driven quality assurance will predict. Like, how can I say this? This is something we do every time. Like we are doing a function, each and every time we grab the data from the process. We select what are the materials we are inserting, how much temperature is set, how much material we are getting, how much time taken for this interposal time. This kind of data will be recorded by using the material or anything. Any method we can collect the data and we can compare the data to find any mistake. If some error won't happen, we can just find from this data. Okay, machine having some data, machine have to done the machine need a service or something. We can determine from this data. Or if you change the material, like raw material is changed, machine taking too much time. So based on the data, we can make a comparison and understand, okay, how to improve ourselves, to improve the quality. I only understand. So the quality management prioritizes the digital tools. We have to build a log data. We have to make a sensor data. Like I told you about, like we use using several sensors. The feedback from sensor will be recorded and collect on this data type. And the machine learning software can be used to check this material and natures and everything. And powder degradation and thermal diffusion, and this kind of negativity